Hi, physics. This is Mr. Janowski. This is the Chapter 13 Study Guide, Problem 3. So, what's going on here? In 1966, the Soviet Venera 3, and that's its mass probe, landed on the surface of Venus. So, this was a probe. This was unmanned, obviously. If you know anything about Venus, yeah, we're not going to be sending people there basically ever. Extremely hot. They have a runaway greenhouse effect. And the surface is hot enough to melt lead, and the pressure is high enough to crush just about anything. But yeah, anyhow, the Soviets, back when there were Soviets, they actually landed a probe there and got some pictures. And this is 3 years before we, the Americans, landed on the moon with people. So ours was better, USA and all. But yeah, anyhow, the Soviets, yeah, they went there. So, real quick etymology here. The name of the probe was Venera. Hopefully, you can see that looks like the word Venus. And yeah, little aside here. If you take health class and you learn about the STIs, sexually transmitted infections, or STDs, sexually transmitted diseases, back in the day, those were called VDs, venereal diseases. Diseases of Venus. So yeah, that's a crazy aside for a physics lecture where we're talking about gravity, but that's how it be. So anyhow, so the probe landed there. That's its mass. There's the mass of. Here's the mass of Venus, and here's the radius of Venus. So what are we trying to figure out here? In part A, we want to know what's the probe's GPE when it's on the surface. So GPE surface is equal to question mark, and what units will this have? Well, it's GPE, and the E stands for energy, and the units of energy are joules. So yeah, there's part A. Part B, let me squeeze these in here going across. Part B is what's the probe's GPE when it's 1 Venus radius above the planet's surface? GPE is equal to question mark joules. Oh, I should have added this. 1R. That's kind of a confusing name for it. We'll see why, but okay, we'll go with that. And then part C. What's the GPE when it was 1,000 Venus radii above the planet's surface? So GPE 1000R is question mark joules. So the key to doing this is, as often is the case, is to have a good sketch of what's going on. So let's start with a sketch right here. So here's Venus, and there is 1 Venus radii. So in the first problem, we're going to be right here. So the distance we're going to use in part A, let me call it D sub A. Should I call it that? No, that's silly. I won't call it that. D sub S for distance when it's on the surface. So it's not 0 because we're on the surface. Remember, when you're doing these things and you're dealing with spheres, you measure your distances from the center of the sphere, and you pretend all of the mass is at the center of the sphere. So anyhow, right here, yeah, D sub S is equal to, well, it's just, where's my cursor? It's just this number right here. That is the radius of Venus. Because when you're on the surface of Venus, you are 1 Venus radius away from the center of Venus. So 6.05 times 10 to the 6th meters. So that's for part A. Let me do it like that. Okay, part A. In part B, when the probe was landing and it was 1 Venus radius above the planet's surface, so it was right about here. It's hard to draw this very accurately. So I was calling this D1R. This is a little confusing because the key idea here is the distance you're going to use has got to be 2 times Venus's radius, because you have 1 radius from the center. So this is getting confusing. 1 radius from the center up to here, and then you have another radius up to here. So it should be twice the radius of Venus. So what number does that end up being? That would be, I'll keep it in the same units to make the math easier, 12.10 times 10 to the 6 meters. So there's your answer for that one. Or I'm sorry, part of your answer for that one. And then in part C, what do we need to figure out? Well, now we have the thing way above, so this is not to scale. But when your probe is way up here, whoop, and this distance here is 1,000. That looks terrible. Should have planned this out better. So yeah, this distance here is. That still looks terrible. Oh well. That's 1,000 Venus radii. So how far are we from the center of Venus when we're 1,000 Venus radii above the surface? For this one, D1000R is going to actually be 1,001 Venus radii. That looks terrible. 1,001 radii Venus. Sorry, I'm off my game a little bit here. So yeah, what number is that going to be? 1001 times 6.05 EE6. And the number we get, whoop, I'm all over the place now. The number we get is, I'll just copy it exactly, 605605000 meters. So count back from the right, put the commas in so we know what's going on here. Boop, boop. Okay, so this, we're going to call this 6.056, we'll ignore the rest, times 10 to the 9th. Because we're moving the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9, times 10 to the 9th meters. So that will be the distance we use in part C. So from here on out, it's just plug and chug. So I'll do just part A, and then I'll just leave it be. There's no reason to make this video too long and keep going into this. But yeah, part A, what's your formula for GPE? So look down at the footer. GPE is equal to minus big G times mass 1 times mass 2 over the distance between them. Okay, so for part A, GPE is equal to minus 6.67 times 10 to the minus 11th times mass 1. Let's make mass 1 the mass of the probe, which this thing was 377 kilograms. Mass 2 is going to be the mass of Venus, which is 4.87 times 10 to the 24th kilograms. Venus is pretty close in radius and mass to the Earth, actually. And all of this we divide by the distance. So remember, for part A, the distance is going to be just one Venus radius, because your distance from the center of Venus to where you are when you're on the surface is one Venus radius. So that is 6.05 times 10 to the 6 meters. So if you do all this, what you're going to get is negative, the negative is important, 2.02 times 10 to the 10th joules. So you put a box around it, and then you do step, does this make sense? Well, we solved for the right thing. We solved for GPE, and we gave it the right units, which is joules. And what did we get? We got a big negative number. It makes sense that it's a big number because it takes a lot of energy to lift something this heavy. So this thing has got a mass of, can't find my cursor. Yeah. So this probe had a mass of 377 kilograms. So that is somewhere in the ballpark of about 800 pounds, probably even more than that. So a big, heavy thing. So yeah, it takes a lot of energy to lift this thing off of the planet. Does it make sense that our answer is negative? Yes, it does. So when you're doing GPE like this, you're always going to get a negative number. So you have to think of it as basically energy that you owe to the system, which means if you want to get this thing away from the surface of Venus, you have to put in a lot of energy in order to do that. So that's why GPE in these problems ends up being negative. So I'm going to stop it there. The other problems are just plug and chug. where all of your numerator will be exactly the same, and you'll just keep switching out the other numbers. So, whoop, this number and this number. You'll keep switching out the denominator, and you should keep getting negative numbers. So yeah. So hopefully you found that helpful.